Hey guys, this is Einar. I hope you're doing great today, and welcome to your 26th tutorial in Basic Statistics in Excel. Now, in this tutorial, we're still talking about correlation, and we're talking about a new correlation coefficient that we call gamma. Now, gamma is kind of different from the percent difference correlation coefficient and the use Q correlation coefficient in that it concerns ordinal data. So what you have is a frequency table like this, and maybe you should take a look on the tutorial about frequency tables if you're unsure about this, because it's very important how you organize this table depending on how you're going to calculate this later. But we're using the same principles we've had before. We're going from low to high here on the theoretical y-axis we can imagine here, and we're going from low to high here on the x-axis that we imagine is placed right here. So if we're taking a look at the formula, it includes a lot of calculations, as you can see. Now what it does, it takes ns minus nd and it divides it by the total of ns plus nd. And what is ns and nd? Well, ns stands for n similar, so we have n similar pairs of frequencies minus nd, which is different pairs of observations. Now, what does that mean? Well, let's take a look. In this frequency table, we're showing the similar parts of the formula, and I've highlighted this by different colors depending on how many times the cell occurs in the formula. So what we're doing is here, we're moving up from a lower left corner to the top right corner, and when you look at these categories here, that actually means that you're comparing similar pairs. So we have in this cell frequencies that have a low value on health and have a low value on social group, so you would say they are similar. And meanwhile, up here at the top we have high values on the x variable and high values on the y variable, so we call them similar for that reason. Here in this table we can see the difference. So this describes different pairs of frequencies. So we begin here at the bottom right corner, where you have low values in the y variable and high values in the x variable. So you would say that they are different. We are comparing different pairs. And it does that all the way up here, where you have high values in the y variable, good, and low values in the x variable, which is low in this case. So that's the whole idea behind this formula, and what we're doing is it's almost like use Q, where we had divided the cell into four parts like this, and we were measuring where is the weight in order to find the strength of the correlation. In this case, we will be measuring the strength by weighting the different parts of the frequency table to see where most frequencies tend to be located. But we're also saying something about the direction of the correlation, because we have now variables at an ordinal level. So let's get started and start calculating this. We begin by counting our n similar pairs of frequencies. We write equal to, and you can just keep track of this while I'm doing this perhaps. You see here we start in the in the bottom left corner, and we move our way up this way. So what we're going to do is going to take this cell multiplied by the sum of all cells above and to the right of this cell. And then we're going to add this cell multiplied by all the cells above and to the right of this cell. So we add them both together. And to that we're going to add this cell multiplied by all the cells above and to the right of itself. Let's see here. There, I don't think I missed it. No, I didn't. Yep. Plus, finally, this cell multiplied by all the cells above and to the right of this frequency table, like so. So this is our n similar, ns. We hit enter, and we get a value for that. So what we've done is we've calculated this part of the frequency table. And if you look at the formula, this is what we've been calculating. If you want to go through it yourself in peace and quiet, so to speak. Okay, so now we're going to calculate n difference. We write equal to, and this time we're going to start here in this bottom corner, and we're going to move our way up this way. Okay, so we choose this cell here, 25, multiplied by the summed up values of all the cells to the left and above of this cell. And to that we're going to add this cell multiply by the sum of all the cells above and to the left of this cell. To that we're going to add this cell multiplied by the sum of all the cells above and to the left of it. And finally, we're going to choose this cell, and we're going to multiply the sum of all the values in this up to the above and to the left of it, which in this case is just one cell right there. So this is the formula for our n different. Hit enter and we get two values here. Now how do we can actually start interpreting these immediately. What we see is here we have a larger value for ns than we have for nd. What does this mean? Well, it means that it seems like the weight in this table is located more in this part of the frequency table than it is there. We have more frequency over here of this table, and that includes these two parts too, but the weight is in this part of the table than that part. And what does that mean? Well, that means that when we go up to high values in x, we tend to get high values in y, and this is what characterizes a positive correlation relationship. So I think we're going to get a positive correlation, because it seems like we were having, if this was a scatter plot, we would have observations going up like this instead of them going down like this. So we'll take one last look at our formula, and we see that. We're going to subtract nd from ns, and since our ns is larger than our nd here, we're going to get a positive value up here, so we're going to get a positive correlation. So let's calculate that. We go here to gamma, we write equal to, and we need a parenthesis first. We take our ns minus our nd, we close the parenthesis, and we're going to divide this by ns plus nd. And that's our gamma formula. All we get is a kind of weak, but still a positive correlation. So that's as I guessed. You see it here. Now, when you're learning this, you can actually try just putting in some extreme values to see how that changes the formula. So if I had, for example, 500 frequencies in this, low and good, so in the different pairs in our frequency table, we would get a negative correlation. You see that? So when we have, now I've moved the weight from here to over here, and that means this n different is going to be much larger than our ns, and we're going to get a negative correlation. I encourage you just to try that out. Put in some extreme values. We could put 500 there and get even stronger, or if we had 10,000 here, we would suddenly get a positive relationship. Just try putting in different values in this table and seeing how the and see how the different values change. And I wish you good luck with this gamma correlation coefficient. I hope to see you in tutorial number 27, and have a nice day. Bye bye.